In this lesson, we're going to look at how to prove parts of congruent triangles are congruent. So what I mean by that is instead of proving the triangles are congruent, if you look at this first example, you're trying to prove a set of angles are congruent. So what we're going to use is a theorem called Cpctc, which stands for corresponding parts of congruent triangles are congruent. And if you think about that, it makes perfect sense, because if I know two figures are congruent, well, then I know everything that corresponds is also congruent. So meaning all of the sides and all of the angles that correspond have to be congruent. So that's exactly what we're going to do here. So let me write out this acronym. So it's Cpctc. And you can abbreviate it because it is a well-known theorem or a well-known acronym. Otherwise, you can write it out. So it stands for corresponding parts of congruent triangles are congruent. So either way, you write it out, you explain it in your own words, or you say Cpctc. So if we look at this first example, we're trying to prove the congruent angles. So what that means is we have to first prove the set of congruent triangles. So in order to prove that angles A and C are congruent, we have to prove that the triangles that A and C belong to are congruent. So angle A, if you look at angle A, it's this angle right here, that belongs to this purple triangle. So that belongs to triangle ABD. So if I prove that that triangle is congruent to triangle CBD, so I'm paying attention carefully to the order of the letters here. So C and A correspond, B corresponds, and then D. So if I prove that those two triangles are congruent first, well, then I can say, well, that would guarantee that all of the corresponding parts also have to be congruent. So that would guarantee that angles A and C are congruent. So this is going to be our first step here. We have to work on trying to get the congruent triangles using one of our methods that we know. So remember, to prove the congruent triangles, we can use SSS, SAS, angle side angle. We can use angle, angle side, and HL dash right triangles. So those are our methods that we can use to prove that the congruent triangles, and then by Cpctc, I'll be able to say that those angles are congruent. So let's go ahead and start writing down our givens and marking our diagram, and let's get to proving that the triangles are congruent. So BD bisects angle ABC. And then that was given, and we also have DB bisects angle ADC. So that's given. And then we're going to label those. So we're bisecting ABC, so that means angle 1 and angle 2 have to be congruent, because we're bisecting angle ABC, creating two congruent parts. So that angle gets split into two congruent parts. So I can say angle 1 is congruent to angle 2, because an angle bisector implies two congruent angles. And then I look at the next given here. It said DB bisects ADC, so that means I'm cutting angle ADC into two equal parts. So I can mark these as 3 and 4, or use 3 letters. And I could have grouped these givens together, since it's basically the same given. You have two different angle bisectors, and then you would have just grouped this stuff, or list them separate. It doesn't really matter. So I have an angle bisector implies two congruent angles again. And then I've used both of these givens to make conclusions. So now what I need to do is I need to look at my diagram, because I've ran out of givens to make conclusions, and I only have two pieces of congruent parts, and I need to get 3 pieces of congruent parts so I can say that the triangles are congruent. So what I want to do now is look at my diagram, look for shared sides or vertical angles. And when I look at this, I can see the reflexive property. I see that shared side. So I can go ahead and say that BD is congruent to BD by reflexive property. And then when I look at this, I can now see I'm supposed to use angle side angle because the side's included between the two sets of congruent angles. So I'm going to just verify that I actually have all of these things in my proof. So my angle, I have one set of angles. The side between those angles I have right here, that's the BD. And then the other set of angles would be 3 and 4, and I have those mentioned. So now I have all of those things mentioned in my proof. So now I can connect them together, those three things, and say that the triangles are congruent. So triangle ABD is congruent to triangle CBD. And this is by angle side angle. And now I can go one step further, and since these triangles are congruent, well, that guarantees that all of the other corresponding parts have to be congruent. So that will make angles A and C congruent, as well as AB, CB, AD, and DC. I don't have to mention all of those because it only asks me to prove angle A and angle C. So now from here, I can just say angle A is congruent to angle C. And my reason for this is Cpctc, or corresponding parts of congruent triangles are congruent, or you could say something like congruent triangles imply congruent corresponding parts. They all mean the same thing. So that is the idea behind Cpctc. So you always prove the congruent triangles, and then you can say any of the corresponding parts are congruent. Now, back when I was doing this, you might have thought, well, I could have done this proof without proving congruent triangles. And that's true, because I could have actually said, since angles 1 and 2 are congruent and 3 and 4 are congruent, and all angles in a triangle have to add up to 180, well, that's going to force angles A and C to automatically be congruent. Because if you subtract off two pairs of congruent angles from 180, well, you're going to be left with congruent angles. So you can use that. There's a reason for that. You have one of those in your angle properties, but for this sake I wanted to show you how to use Cpctc, because depending on that rule won't always work, and more commonly we use Cpctc. So let's look at one more. So this one here, I want to prove again a pair of congruent angles, so a pair of congruent parts. So right away this indicates that you have to first prove congruent triangles. So as soon as you see that, that indicates first prove congruent triangles and then use Cpctc. So if we look at the angles we're trying to prove, C and D, I don't want to mark them with an R because I don't know if they're congruent yet. So let's look at the triangles that these angles belong to. So we have angle C is going to belong to triangle ACE, and then angle D, if we look at angle D, we just connect it, make a triangle out of it, it's going to be triangle DBE. So the triangles that we're going to prove are congruent. So let's look at the order of the letters here. It's going to be ACE is congruent to, so it's going to be B because D and C correspond, so B, D, E. So there's where I need to go. And before I do that, let's go ahead and mark our givens and work on getting those triangles are congruent. Then I can use Cpctc. So my first thing here is to write down my givens. So AB and CD bisect each other. So that's given. So AB and CD are bisecting each other. It means each segment is cutting each other in half. So it means I have these two parts are equal and then these two parts are equal. So from here I can actually make two conclusions. So I can say CE is congruent to ED. And I can also say that AE is congruent to EB. And I group those together because I'm going to use the same reason for them. So a segment bisector implies two congruent segments. And notice when I marked my segments, I used different number of arcs or different number of slashes so that you could tell which ones were congruent to each other. They're not all four congruent to each other. So I've used my givens. So now I need to look at the diagram, make any conclusions from the diagram. So when I look at the diagram, I see vertical angles right away. So I see 1 and 2 have to be congruent. So I can say angle 1 and angle 2 are congruent because vertical angles are congruent. Remember, I saw the X in the diagram. That's how I knew vertical angles, so I can check that off. And then when I look at this, I see side angle side is my method because I have the angles in between the two sets of congruent sides. So now if I actually go and verify that I have all the pieces, well, I have a set of sides. I have the angles between them right here mentioned in my proof. And then the other set of sides is right here. So I have all three pieces of information to say side angle side. So I can group those together. Say that the triangles are congruent by side angle side. So triangle ACE is congruent to triangle BDE by side angle side. And then from there, since the triangles are congruent, well, that makes all of the other corresponding parts congruent. So now I can say angle C is congruent to angle D because it's a set of corresponding parts in congruent triangles. So this is Cpctc. So corresponding parts of congruent triangles are congruent, or I could say congruent triangles imply the corresponding parts are congruent. So that's the idea of these proofs. So always prove that the triangles are congruent first using one of your 5 congruence theorems, and then from there you can say any other parts are congruent because the triangles are congruent and all of the corresponding parts have to be congruent. So go ahead and try the check your understanding problem, get your key ideas down, and then go ahead and try the practice or the problems on that page.